Welcome to STEM Professionals. In this video, we will discuss the problems and conceptual exercises of Chapter 2 from the book James S. Walker. So let's start with the video. Now here in this question, we are given with the position versus time graph for a father. And we have to indicate whether the father's velocity is positive, negative or zero on each of the following segments of the graph. And segments we have A, B, C and D. Now the concept that we're going to use here is that the slope of a line on xt graph, that is position versus time graph, will tell you the velocity of the person or object for that time interval. Now for the segment A, the slope of this line will tell you the velocity of the father. Now if the slope is positive, then the father's velocity is positive. If the slope is zero, then the father's velocity is zero, and similarly if the slope is negative, the velocity would be negative. Now here this slope would be positive for this segment A. So since slope is positive, so velocity, let me write here first for segment A, the velocity will be positive since slope is positive. Now for segment B, now it's a horizontal line, so slope would be zero, so velocity will be zero since slope is zero. Now for segment C, you can tell easily that if the slope is positive, so velocity would be positive, same reason, slope is positive. And finally for segment D, now this slope is negative. This slope is negative because this theta is greater than 90 degree. So slope negative means velocity will be negative. So for segment D, the velocity is negative. And the reason is because the slope is negative. Now next we have to find the numerical values of the velocities. So we'll do it one by one. So for segment A, now the average velocity for segment A would be the slope of the line of this line, this one. This is delta x over delta t. This is the way we find slope. Now delta x, we have this value, which is, let me show it on the figure first. This is delta x, this is delta t. So delta x we have 2, so 2 divided by 1. So 2 divided by 1, which is equals to plus 2. Same thing we have calculated, we have integrated here also. Slope velocity is positive, and here also the velocity comes out to be as positive. Now for the segment B, the velocity would be equals to, now here this is horizontal line. This is for segment B. So slope is 0 because delta x is 0. So velocity would be 0, and same thing we have indicated here also. Similarly we can do it for the segment C. So the slope would be, this would be delta x here, and this would represent delta t. This is delta t, this is delta x. So delta x would be 3 minus 2, which is 1. Delta t is 3 minus 2, which is also 1. So slope for this is segment C, this would be 1 over 1, so this would be plus 1, and the same thing we have indicated here also. Now finally, now here the slope, now this would be the delta x, and this would represent the delta t. Now this is the initial position and this is the final position. So delta x would be 0 minus 3 because here x is 0 and here x is 3. So delta x would be 0 minus 3, which is minus 3, divided by delta t. Now delta t would be, this is final, so 5 minus 3, because we have to take final minus the initial value. So 5 minus 3 is 2. So this would be 2. So that value comes out to be as negative 1.5 meter per second. And here the velocity is negative, and the same thing we have indicated here also, that for segment D the velocity is negative. Now here in this question we are given that the position of a particle as a function of time is represented by this equation. x equals to 6t minus 2t square. Now there are three parts in this question that we need to solve. In the A part, we have to plot x versus t graph for the time interval t equals to 0 to t equals to 2, and for that you can use a graphing calculator, or you can use any online graphing calculator available. So we have obtained this curve, and this is x versus time graph, and this curve represents this equation. Now in the B part, we have to find the average velocity of the particle from time interval t equals to 0 to t equals to 1. So here this is t equals to 0, and here this is t equals to 1, and this would be the point. Now to find the average velocity using the xt curve, we have to join these 2 points with a straight line, something like that, and the slope of this line will tell you the average velocity of the particle from time t equals to 0 to 1. Now slope, we know it is delta x over delta t. So this would be delta x and this would be delta t. So delta x, we have this is the final position and this is the initial. So this would be 4 minus 0 divided by, this is 1 minus 0. So this would be equals to 4, and since slope is positive, so velocity is also positive, and it would be equals to plus 4 meter per second. So this would be the average velocity of the particle from time interval t equals to 0 to 1 second. Now in the B part, we have to find the average speed from time interval t equals to 0 to t equals to 1. Now in this case, since the object is moving in positive x direction, because for this time interval the position is increasing. So in this case, the average speed would be the magnitude of average velocity. This is for the B part. Now C part, average speed. This is magnitude of average velocity. So magnitude of 4 would be 4 only. So this is 4 meter per second. So this would be the answer for the C part. So here in this question, we are given that on the wedding day, a person leaves for the church 30 minutes before the ceremony, and the church is 10 miles away from his home. Now due to construction work on the way to church, his speed for the first 15 minutes is only 5 miles per hour. Now we have to calculate, or we have to tell that what should be the average speed for the rest of the trip so that he can reach the church on time. So this is the question. Now first of all, I've made this coordinate system. Here this is x equals to 0. From this position his journey or his motion starts, and this is x equals to 10 miles where the church is. Now the strategy that we're going to follow is, first we're going to find the distance traveled for the first 15 minutes, and then we can determine the speed you need to have for the next 15 minutes so that you can reach on time. Now for the first 15 minutes the average speed is 5 miles per hour. Now we know that distance d1 would be equals to speed s1 multiplied with the elapsed time t1. So s1 is 5 miles per hour. Now since the time is given in minutes, so we have to convert the units into miles per minute. So we know that 1 hour is 60 minutes multiplied with delta t is 15 minutes, because he traveled at this speed only for 15 minutes. So multiplied with 15. So this would be equals to 1.25 mile. So initially for the first 15 minutes he traveled only this much of distance. So let me show this on the figure. So here it must be x equals to 1.25. So in the next 15 minutes he should travel this much of distance, this much. Now this total distance is 10 miles. So this distance would be 10 minus this value, 1.25. So this would be 8.8 mile. So in the next 15 minutes, he should cover 8.8 mile. Now his speed would be S2 would be equals to D2 over delta T2. Now D2 we have this much of distance, it should cover 8.8 mile. Divide by, now time we have 15 minutes. So let us give the answer in miles per hour because the input data is given in miles per hour. So for that you have to convert 15 minutes into hour. So 15 minutes is 1/4 of an hour. So we can write 0.25 hour. So that would be equals to 35 miles per hour. Therefore, the average speed for the next 15 minutes should be 35 miles per hour so that he can reach the church on time.